The mean of a binomial distribution with parameters big N and P is given by the sum over k from 0 to n of k times the PMF of k. Now that should say binom, but first we'll split off. What's going on here? First we'll split off k equals 0. So basically the first element, because that will be 0, and we're left with this. Then that again should be binom. The PMF of the binomial is n choose k times p to the k times 1 minus p to the n minus k. So we substitute that in. Then we rewrite n choose k as n factorial over k factorial times n minus k factorial. And then these k here cancels with this k, with one of the k's here, leaving k minus 1 factorial. And then what we do is we can just factorize. N factorial is equal to n times n minus 1 factorial. So we'll then, because n is independent of k, we can bring that outside the summation. Next, we take out p to the k is the same as p times p to the k minus 1. So again, we'll take out p, and then we are left with this expression here. Now, n minus k is the same as n minus 1 minus k minus 1, because what we're heading for here basically is to get we want to get a n minus 1 choose k minus 1 binomial coefficient. So we rewrite n minus k like this, and that gives us this expression. Here and here is where we made the rewrite. The next, we rename our local variable k to k plus 1. And when we simplify, we now have n minus 1 here and 0 here. And we now have n minus 1 over k factorial times n minus 1 minus k factorial times p to the k times 1 minus p to the n minus k. So we can see pretty clearly that all we need to do is then substitute n becomes n plus 1. So that gets rid of the n minus 1. And then we have n factorial over k factorial over n minus k factorial. And then, using binomial coefficients, we just rewrite this expression to this and choose k. Then we apply the binomial theorem, which tells us that x plus y to the n is equal to the sum over k from 0 over 0 to n over n choose k times x to the k times y to the n minus k. In this case, x is p and y is 1 minus p. And so this long summation becomes this nice compact expression, which simplifies, well, p minus p is 0 plus 1 is 1. 1 to the power of n is just 1. So that's 1 is a unit of multiplication. So we're just left with n times p, which is the mean of the binomial distribution.